Welcome to today's lesson on field operator responsibilities in distillation columns. We'll also dive into the distillation process and explore the different types of distillation columns used in the industry. Whether you're a student, a professional, or just curious, this video will provide you with valuable insights. Let's get started. Now, we have to divide this video into 5 sections. Section 1. What is distillation? Section 2. Types of distillation columns. Section 4. Types of column trays and packing. Section 3. The distillation column process. Section 5. Field operator responsibilities in distillation columns. Okay, let's start. What is distillation? Distillation is a key separation process used in the oil and gas, petrochemical, and chemical industries. It works by separating a mixture of liquids based on differences in their boiling points. The process typically involves heating the mixture to vaporize the more volatile components, which then rise through a distillation column, while less volatile components remain as a liquid. Wait, I'm explaining to you simply. Volatile components are substances in a mixture that tend to vaporize or evaporate at relatively low temperatures. In other words, they have lower boiling points compared to other components in the mixture. Because of their low boiling points, volatile components are more likely to turn into vapor when heat is applied. For example, in a mixture of water and alcohol, alcohol is more volatile than water because it has a lower boiling point. During distillation, the alcohol will vaporize first, allowing it to be separated from the water. I think you got the point right. Section 2. Types of distillation columns. There are several types of distillation columns used in the industry, each with its own design and application. Let's take a closer look at the main types. 1. Continuous columns. Operate continuously, handling a steady flow of feed and products. For example, in a petroleum refinery, continuous distillation is used to separate crude oil into its various components, such as gasoline, diesel, kerosene, and other products. The crude oil is fed continuously into the distillation column, where it is heated. This process runs 24/7 to meet the high demand for refined products. Common types include fractional distillation columns and vacuum distillation columns. 2. Batch columns operate in cycles, processing fixed quantities of feed in each batch. Used in smaller scale operations or where flexibility is needed. For example, in the pharmaceutical industry, batch processing is often used to produce medications. For example, a batch of a specific drug might be produced by mixing active ingredients and excipients in a reactor. Once the mixture reaches the required specifications, the entire batch is removed from the reactor for further processing, like drying, pressing into tablets, or packaging. After the batch is completed, the equipment is cleaned and prepared for the next batch, which could be the same product or a different one. So next, Section 3. Types of column trays and packing. Distillation columns often use trays or packing to enhance the separation process. Note these points. This will help you for the interview. Here's a quick overview of the different types. Types of trays. Bubble cap trays. These use caps to direct vapor through the liquid, creating bubbles and enhancing contact. I will make another video explaining about all the trays. Sieve trays. Simple perforated trays where vapor passes through holes. Valve trays. Trays with movable valves that adjust to vapor flow, offering better efficiency. Then packing. Random packing. Small pieces like pole rings dumped randomly into the column. Structured packing. Carefully arranged sheets or grids, offering high efficiency and low pressure drop. 4th point, the distillation column process. Now, let's break down the distillation column process step by step. 1. Feed introduction. The feed mixture is introduced into the column at a specific feed tray or point. Feed is most important because without feed, we cannot produce products, mostly in the refinery. The feed line is typically connected to the middle section of the column. This position is chosen based on the composition of the feed and the desired separation. Why the middle section? Lighter components. When the feed enters the column, components with lower boiling points, more volatile, move up the column toward the top. Heavier components. Components with higher boiling points, less volatile, move down the column towards the bottom. 2. Heating. The mixture is heated, causing the more volatile components to vaporize and rise through the column. 3. Vapor-liquid contact. Vapor-liquid contact in a distillation column is the key interaction that allows the separation of components based on their boiling points. As the vapor rises through the column and the liquid descends, they come into contact on trays or packing, facilitating mass transfer between the two phases. How it works. Rising vapor. The vapor, which contains more volatile components, rises up the column. Descending liquid. The liquid, which contains less volatile components, flows downward. Mass transfer. As they come into contact on trays or packing, the vapor gives up some of its less volatile components to the liquid, and in return, it picks up more of the volatile components from the liquid. This exchange continues as the vapor and liquid move through the column. In this case, trays and downcomers play a major role. Descending liquid will hold on trays with the help of a weir. And overflow of liquid goes through downcomers. Example: in a distillation column, separating ethanol from water. The rising vapor is enriched with ethanol, more volatile. The descending liquid becomes richer in water, less volatile. As they contact each other on the trays or through packing material, ethanol transfers from the liquid phase to the vapor phase, while water transfers from the vapor phase to the liquid phase. This repeated contact at each stage, tray or packing layer, increases the purity of the ethanol in the vapor as it moves up the column and the purity of the water in the liquid as it moves down. 4. Condensation. The vapor at the top of the column is condensed into a liquid, which is collected as the overhead product. This part of the process needs more heat exchangers. Mostly for condensation, exchangers work with sea cooling water. In every unit battery limit, the battery limit means a junction for all incoming and outgoing pipelines. In battery limit, there is a sea cooling water supply, and a return line will be there for every unit. Supply line connects with the exchanger shell side bottom, and the return line connects with the shell side upwards. Hot vapor enters the condenser in a tube, typically from the top or side. There is another type of condenser, is the air fin fan cooler. It uses ambient air to cool and condense the vapor. I will explain you in another video. 5. Reboiling. A reboiler is a type of heat exchanger used in distillation columns to provide the necessary heat to vaporize a portion of the liquid in the bottom of the column. This vaporization is essential for the continuous operation of the distillation process, as it helps maintain the necessary temperature and facilitates the separation of components based on their boiling points. Most kettle types of reboilers are used in all industries, but there are two more types: thermosiphon reboilers and forced circulation reboiler. 6. Reflux. Reflux is a key concept in distillation processes involving the partial return of condensed vapor, reflux, back into the distillation column. This process improves separation efficiency by creating a temperature gradient and increasing the interaction between the vapor and liquid phases. How reflux works. Vapor from the top of the distillation column is condensed into a liquid in the condenser. Part of this condensed liquid is sent back into the column as reflux. The reflux liquid flows downward through the column, coming into contact with the rising vapor. This interaction between the reflux and the vapor improves the separation of components, as the reflux helps to redistribute the components within the column, providing better separation and increased purity of the desired product. After condensation of liquid goes to the reflux drum, which helps to store the distilled liquid. Then how it will go to column return. In between the reflux drum to column, one pump is there, which is called the reflux pump, which helps to transfer liquids. Types of reflux. Total reflux. All of the condensed vapor is returned to the column as reflux, which maximizes separation but may result in lower product recovery. Partial reflux. Only a portion of the condensed vapor is returned as reflux, allowing for the collection of a portion of the product while still achieving effective separation. Reflux is a critical part of the distillation process, ensuring effective separation and high purity of the desired products. Section 5. Field operator responsibilities in distillation columns. Field operators play a crucial role in the operation of distillation columns. Their responsibilities are very important for every shutdown and startup time. So, I've listed down the field operator's 5 important procedures for working on distillation columns. So first one, pre-startup check. Pre-startup checking work is a very important one. If you do this work properly, you can control accidents and product loss. Now I'm going to tell you points by points, so note these points. 1. Inspect the column using P&ID. In this P&ID, you can get all the details about the column, like you can see all instrument parameters, valves, control valves, and rating of the gaskets, and you can cover all the loops of the column. So using P&ID, check the column top to bottom to ensure all drain valves are closed. If any of the drain valves open condition during startup time, that will cause major accidents and product loss. So always close all drain valves before starting up, open all pressure and temperature gauge valves, and cross-check with the panel person, like ask how much pressure showing on the panel for this PI 2301, they tell you the pressure. Then you once check it on the field. If it's same, no problem. If there is a different, you contact to instrument persons to check the indicators, and you can check with pressure gauge also. 2. Verify all the loops. You have to verify all the loops or the particular loop before startup. As a field operator, you have to know all the loops. If the engineer gives you a loop or system, you should trace all the lines using P&ID. It is very hard to trace, but once you finish, you are the king in that particular work. Check the loop as per P&ID, because this spectacle blind was open as per P&ID. In the field, if it's closed, you have to reverse the blind. 3. Ensure all instruments are in working condition. As I told you before, you can check with P&ID and check with DCs or a panel person. 4. Ensure all the valves are working condition. Check all the valves. If it is hard to open, do greasing. If the valve handles stem or body parts broken condition, you have to contact the valve technician. And importantly, check whether all the control valves stroke check was done or not. 5. Check the all loops from the start, like the feed to the product. In this image, you can see a simple distillation process, P&ID. I will tell you simply for today's video. Now I'm taking the column and bottom product loop. You can see some valves are there. Now we are going to line up the column bottom loop. So check column first. Ensure all manways are closed and torqued. Close all drains from the column. And here at bottom, you should line up this control valves or open bypass valves. Line up this flow indicator also closes drain valves. 6. Ready all the pumps for startup activities and ensure MRT was done before or not. In the refinery before startup, they run all pumps with flushing oil. So check all the pumps which are connected to the column. 7. Line up all pressure safety valves at the top of the column. Every vessel has 2 PSV, A and B. You should always line up any one of the PSV to flare, means close flare, bypass valves, and open upstream and downstream of the PSV's valves. These are the pre-start checks. If I forgot anything, please write it in the comments. Then next, startup procedure. 1. Introduce the feed by opening the valve or control valve with the help of a panel person, because they monitor flow and pressure. They assist you from start to end, so every time, be in contact with a panel person. Don't open valves by your own instincts or overconfidence. 2. Check all exchanges parameters. 3. Check control valve operation. If the panel person tells you the pressure control valve not operating, then you have to change the lineup to bypass. 4. Check the whole loop and monitor all the things, like flange leaks, gas leaks, and choke. Rectify if it happens using workers by giving proper PPE. And always take the LEL checking device with you. 5. Be ready to start the pumps, because once feed comes, you have to start the pump from the feed drum to the heater or any vessels. Procedure 3. Operational monitoring. If the plant goes smoothly after shutdown, it's heaven for field operators. 1. Monitor all the parameters of the vessels, exchanges, pumps, and compressors. 2. Regularly check temperatures, pressures, and flow rates. 3. Take samples and ensure product quality using glass bottles, latex rubber bladders, and gas sampling bombs. But if any problems come after startup, it's a sleepless night for operators, like pump changeover and stainer chock, compressor trips, heater trips, pipelines chock, and any leaks. Next video, I will explain to you in detail how to shut down and start up the column maintenance and troubleshooting. 4. Shutdown procedure. Gradually reduce feed rate and heat input, safely depressurize, and inspect equipment post-shutdown. How we line up all valves for startup. Same in shutdown, we have to close all the valve from starting. Lockout, tagout. Implement lockout, tagout procedures to prevent accidental startup during maintenance or inspection. Shut off utilities. Turn off all remaining utilities, such as cooling water, steam, and power to pumps. Inspect equipment. After the shutdown, inspect all components, including trays, packing, reboiler, and condenser, for any signs of wear or damage. Perform necessary repairs. Carry out any required maintenance, cleaning, or repairs before the column is restarted. 5. Maintenance and troubleshooting. Maintenance and troubleshooting are essential activities for ensuring the reliable and efficient operation of a distillation column, particularly in the context of a field operator's responsibilities. Maintenance of a distillation column. 1. Regular inspections. Visual inspection. Regularly check the exterior of the column, piping, and associated equipment for signs of leaks, corrosion, or damage. Instrument calibration. Regularly calibrate and test all instrumentation, including temperature, pressure, and level sensors, to ensure accurate readings. 2. Cleaning procedures. Mechanical cleaning. For severe fouling, mechanical methods such as brushing or hydroblasting may be necessary to clean trays, packing, and other internal surfaces. 3. Gasket and seal. Replacement. Regularly inspect and replace gaskets, seals, and other components that are subject to wear and tear to prevent leaks and ensure proper operation. Troubleshooting. Common issues. there is 6 issues or problem in distillation process. As field operator, need to troubleshoot 1. Column flooding 2. Weeping or dumping 3. Pressure drop issues 4. Temperature control problems 5. Product contamination 6. Reboiler and condenser issues. Last is safety. Safety is a paramount concern in the operation and maintenance of a distillation column, as well as in the broader context of the oil and gas industry. Ensuring the safety of personnel, equipment, and the environment involves adherence to stringent safety protocols, regular training, and the use of protective equipment. Safety considerations for distillation columns. 1. Personal protective equipment, PPE. Ensure that all personnel wear appropriate PPE, such as helmets, safety goggles, gloves, and steel-toed boots or safety shoes. 2. Hazard identification and risk assessment. Regularly conduct hazard identification studies to identify potential risks associated with the distillation process, like material fall, chemical spillage. 3. Gas detection systems. Install gas detection systems to monitor for the presence of flammable or toxic gases and ensure they are regularly calibrated and tested. 4. Safe handling of chemicals. Ensure that MSDS means Material Safety Data Sheet for all chemicals used in or produced by the distillation process are available and understood by all personnel. 5. Emergency response preparedness. Develop and practice emergency response procedures for scenarios such as fire, explosion, toxic gas release, and spill containment. There is an end of the video. Section 6. Conclusion. To wrap up, distillation is a critical process in many industries, and the role of field operators is essential for ensuring its success. Understanding the different types of distillation columns, the process itself, and the responsibilities involved can greatly enhance the efficiency and safety of operations. Thanks for watching. If you found this video helpful, don't forget to like, share, and subscribe for more content on industrial operations and processes. See you next time.